Yeah, you might say that, oh no, not again, this guy. I promise I will not have any more presentation today. Okay, so now I'm going to talk about our Tautomer tools. Basically, we have 4 different methods to handle tautomers in the database, and I will also talk a little bit about the Tautomerization plugin, which is the foundation of all of the methods. So first of all, what is Tautomerization? So, on the slide, I have some screenshots from Wikipedia. Basically, Tautomerization is a transformation, an isomerization process which takes place instantaneously in nature. So the different tautomeric forms convert into each other very rapidly. Now, there are different forms of tautomerization. The most important one is the proton transfer tautomerization, where a hydrogen atom actually moves to another position, and during the process, the single-double bonds change between the atoms. Okay. There are other types of tautomerisms available, but some chemists consider them tautomerizations, some others are not. So basically, this proton transfer tautomerization is the most widely accepted definition for tautomerism. Now, we have a tool, a calculator plugin, which is able to predict these tautomerization mechanisms. It is implemented as a calculated plugin, so it is available from Marvin Sketch, but also from the cartridge and from command line and the API, and then as all the other calculator plugins. So what can it do? It can predict the tautomers. I will start with the all tautomers, so all the theoretically possible transformations can be enumerated. The dominant tautomer distribution is from the all tautomers is that set which is likely to appear in an aqueous solution and at a given pH, and we using our methods, particularly our pK estimation, we can also estimate the ratio of the different dominant tautomers, so that we can predict that that particular tautomer is present at 90% of the cases, and these 3 are the rest, and so on. Okay, we can the tautomer with the highest distribution is the major tautomer. We have that too. And we also have a canonical tautomer algorithm, which can be useful in the database to represent many different tautomers. And the generic tautomer can be used for the same purpose. I will talk about this later. So this slide shows the process, how we identify the tautomers. First, we identify which are the atoms which can lose or accept a proton. Then we filter them, so remove them based on the parameters of the plugin, and then we consider the paths between these acceptors and donors, and then based on the method, we either enumerate, combinatorially enumerate all the possibilities, or rank the results to get a dominant or a canonical tautomer, or and then calculate the distribution for the dominant tautomer. And in case of the generic tautomer, we combine these into tautomer regions. I will tell where it is useful. Okay. Well, okay. We've got tautomers. We can use them to enhance property predictions. For example, logD and pk and logP. We either use the full dominant distribution or just the major one. Okay, and there are different methods that can be used when we want to search for tautomers in the database. The first method is a table option. It is called duplicate search uses tautomers. Okay, I think it's a quite descriptive name. When this option is on, it means that all the duplicate searches in that table will consider the tautomerization. For this method, we use the generic tautomer, and basically we convert the query to the generic tautomer, convert it to a hash code for screening, and we use that hash code and the generic tautomer in the atom-by-atom phase. Okay, what is this generic tautomer? This generic tautomer is basically, we get it by identifying the tautomeric regions, those regions in the molecules which are local environments where individual tautomerization mechanisms occur. Now because the bonds in this region changes, then we replace the bonds with any bonds and make note some of the important information about the regions. For example, the number of electrons and the number of deuterium and tritium atoms to be able to identify what was the original structure. Okay, this is the algorithm to generate this generic tautomer. I won't go into detail now. It is very useful to recognize all the theoretically possible transformations, tautomeric transformations. However, the stereochemistry can give us surprises. Okay, in theory, when we start off with a stereo molecule which contains a tautomerizable functional group, basically what happens in nature, then the tautomerization happens on one direction instantaneously, and then it goes back. So it means that this double bond is lost. So basically the stereochemistry is also lost. And so what we end up here is a racemic mixtures, so with unknown stereochemistry. Okay, it is all okay, nice, but what if the theory is not right? So what if the tautomerization does not take place? Okay, for this reason, we have introduced an option into the tautomerism mechanism to be able to protect different kinds of stereochemistry. So for example, there is an option to protect double bond stereochemistry and an option to protect the tetrahedral stereochemistry. Now, and this slide shows how we use it in the database. So basically, we always protect the tetrahedral stereocenters because they are usually put there for a reason. And we do not protect the double bond stereochemistry because it's very easy to sketch a structure in a way so that we just accidentally draw the structure with cis or trans configuration. Okay, so as a result of that, basically, these are the different categories that we end up with this method. Another method is the tautomer search options. In this case, we basically just take the query structure, enumerate all the tautomers, and do the searching with each tautomer. And this can be a lengthy process when there are many tautomers of the query. Okay. Another method is to use Standardizer. Yuri was talking about Standardizer before. Here we can either use the canonical tautomer transform or draw up specific transformations so that all the structures are converted into the preferred tautomer. Okay? And this method also allows a lot of flexibility, and all those advanced different kinds of tautomerisms can be also represented using this method. For example, ring chain tautomerism. Okay, this large ugly table is a comparison of the methods. I won't read it loud. And we have a few further developments are in the pipeline, and most of these are going to come out in the 5.4 version. Okay. At the end, I would like to show the development team. Basically, most of the development was done by Józsi Szegezdi. He created the calculator plugin, the Tautomerization plugin, and Zsolt worked on the plugin framework. Tamás and Szilárd worked on the integration into JChem, and Ákos, Gyuri, Chizi, and myself were helping with the concept and finding out the algorithms and so on. So the calculator plugin, to sum up, the calculator plugin gives several methods to predict different types of tautomers, and it can also improve property predictions. And JChem offers 4 ways for searching tautomers. And thank you for your attention.